All right, class, next section, 3.4, find and use slopes of lines. So you guys are going to be able to calculate slope and graph lines. So the slope formula we talked about a little bit last time. It is m for slope, equals y2 minus y1 over x2 minus x1. And that gives us our rise over run. And that what rise over run is simply the change in your y values and the change in your x values. Run is the change in x values, rise is the change in y's. So a positive slope, if we graph it, is going to look something like this. It's going to start at the bottom left and move up toward the right. And that would be from a positive rise over run, or a positive slope. A negative slope is going to look the other way. The graph is going to go the other way. It's going to start at the top left and go to the bottom right. And that would be if we had a negative sign in front of our slope. So a negative rise over run. An undefined slope is going to look like a vertical line straight up and down. And that would be if we have whatever number we have in our rise over 0, if there is no change in x. So if in our slope formula, looking back at the top here, if we had our 2 points for x were 2 and 2, we would have to do 2 minus 2. That would give us 0. So if we ended up with 0 for our run, our graph is going to be undefined. So it's going to be a vertical line. Our slope is going to be undefined. It's going to be a vertical line. A 0 slope is going to be a horizontal line. And that is when the change in the y's is 0. If we get a 0 for our rise, and then have another number for our run, that would be a 0 slope. Parallel lines. Parallel lines have the same slope. So any lines that have the same slope are going to be parallel lines. And parallel lines don't cross. They don't cross, they never get closer or further apart. They're just parallel, and you're going to see them marked with those little arrows, which means parallel. So if you ever see those markings, that means they're parallel lines. So parallel lines have the same slope. Perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. So your perpendicular lines, that's two lines that intersect to form 90-degree angles. And you'll always see the right angle marked. So that would mean it's perpendicular. Now, what do we mean by the opposite reciprocal? An example of that is if we had a slope of 2 over 3, the opposite reciprocal of that is negative 3 over 2. So we would have a negative sign because we need to change the sign. It's the opposite sign. And then the reciprocal means flipping the fraction. So if our slope's fraction was 2 over 3, we would flip that to 3 over 2 and make it negative. All right, in this example, we need to find the slopes of lines A and B and tell if the lines are perpendicular. First, we need to change. We've got the same line labeled both A and B. Let's call this one B. And the other one can stay at K. All right, so first we need to find the slope of A. We need the slope of A. So let's look at the points that we have on A. We have 0, 2, and 4, 6. So we need our y2 minus y1. So 6 minus 2 over x2 minus x1, which is 4, minus 0. So we have 4 over 4, which simplifies to 1. So our slope of A is 1. Then we need to find the slope of B. And our points that lie on line B are 4, 6, and 7, 3. So we'll take our y2 minus y1, so 6 minus 3, over x2 minus x1, 4 minus 7. So we get 3 over negative 3, which simplifies to negative 1. So our other question was, are they perpendicular? Are those lines perpendicular? Are the slopes of the lines opposite reciprocals of each other? And the answer is yes. If we flip these fractions at the top, it would just still be 4 over 4 or 1 over 1. And then on the bottom, we are flipping the fraction to 3 over 3, which is still just 1 over 1, and we're adding in that negative sign. So we have the opposite sign, and 1 over 1 is still the reciprocal of 1 over 1. So yes, they are perpendicular. Yes, they are perpendicular. All right, so on this one, let's find the slopes of C and D and tell whether the lines are perpendicular. So first, let's look at C. We want to find the slope of C. So slope of C, we have on line C 4, 6, and 0, 6. So we'll take 6 minus 6, our two y's subtracted, and then 4 minus 0, our two x's. So we get 0 over 4, which simplifies to 0. 0 divided by any number is 0. So our slope of C is 0. Then we need to find the slope of D. And the points that we'll use for D that lie on point D, or line D, are 4, 6, and 4, 0. So we have 6 minus 0, and 4 minus 4. So we get 6 over 0, which simplifies down. And anytime we divide a number by 0, it is undefined. Undefined. You cannot divide by 0. So the other question is, are they perpendicular? So we have a slope of 0, which is a horizontal line, and a slope that's undefined, which is a vertical line. Does a horizontal line and a vertical line meet at 90 degrees? Yes. They are perpendicular. 0 and undefined are opposite reciprocals of each other. But you know that a vertical line and a horizontal line, perfectly vertical and perfectly horizontal, are going to intersect, form 90-degree angles. So yes, they are perpendicular. In this example, we need to tell whether the lines through the given points are parallel, perpendicular, or neither, and justify our answer by finding the slope of each line. So we need to find the slope of these lines. So let's start with line 1. Remember, our slope formula is y2 minus y1 over x2 minus x1. So if I were to call this x2 and y2, this would be my x1 and y1. So I would have 7 minus 2. That doesn't need to be in parentheses. And then negative 5 minus negative 9. That one probably should be. All right, so 7 minus 2 gives us 5. And negative 5 minus negative 9 is really negative 5 plus 9. So that's 4. So our slope of line 1 is 5 over 4. And then line 2, we call negative 13 x1 and 6 y1, negative 6 x2 and 2 y2. Plug that into our slope formula. We would have 2 minus 6 over negative 6 minus negative 13. So I have negative 4, and then negative 6 plus 13 gives me positive 7. So that is my slope. The slope is negative 4 over 7. So are they parallel? Remember, to be parallel, the slopes have to be the same. 5 over 4 is not the same as negative 4 over 7, so they're not parallel. Are they perpendicular? They need to be opposite reciprocals of each other. So we have 5 over 4. The opposite of that would be a negative. So we do have the negative, but it's negative 4 over 7 instead of negative 4 over 5. So they're not perpendicular, so they have to be neither. Neither. Here we need to graph the line through the point negative 4, 2 with a slope of negative 5 over 2. So I'm going to make a graph. So this is my graph. We have a point at negative 4, 2. So 1, 2, 3, 4, up 2. There's my point at negative 4, 2. And we need a line that goes through that point with a slope of negative 5 over 2. So I'm going to start at that point, starting there at that point, and I need to use my slope of negative 5 over 2. So that would be down 5 and right 2. So if I go down 5, right 2, 1, 2, 3, 4, 5, and to the right 2, 1, 2. My dots are not lining up properly. Right in there, and that is at negative 2, negative 3. So my line will go through there. My line can also go up 5 and left 2. So if I go up 5, 2, 3, 4, 5, and left 2 would be over here. And that would be at negative 6, positive 7. And so my graph also, or my line also extends that direction. So you can see my graphed line does have a negative slope. It starts at the top left and goes toward the bottom right. And it has that slope of negative 5 over 2, which is just down 5, right 2, or up 5, left 2. So that negative can be applied to either the rise or the run. If it's applied to the rise, you go down. If it's applied to the run, you go to the left. On number 5, we need to graph the line through point A at negative 2, negative 4, and point B, 5, 2, and then graph the line that passes through 0, 3, and is parallel to line AB. Line AB, made by our first 2 points. So I'll draw my graph. We have a point at negative 2, negative 4. So at negative 2, negative 4, our point would be right there. Then we also have a point at 5, 2. And our point would be right about there. So this is a point B, and this was point A. So there's our line that passes through those 2 points. Next, we need to graph a line that passes through 0, 3. So starting at 0, I go up 3. So we need a line that passes through that red dot and is parallel to AB. So how do we know how to make a line parallel? We need to know the slope of the line we want it to be parallel to. They need to have the same slope. So we need to look at our line, our blue line, and find the slope of that. So there's 2 ways we can find the slope. We can count it out, count out all of our spaces to the right and left, or right or left, and up or down. or we can use our slope formula. So if I just use the slope formula, I have 2 minus negative 4 over 5 minus negative 2. So 2 plus 4 is 6, and 5 plus 2 is 7. So I have a slope of 6 over 7. And if I count that out on my graph, I should have a rise of 6 and a run of 7. So let's see if we get 7 to the right. We go 1, 2, 3, 4, 5, 6, 7. And 6 up. 1, 2, 3, 4, 5, and 6. So yes, that is our slope. It matches up. So we need to draw our line through the red dot with a slope of 6 over 7. So we need to go up 6, right 7. 6. And to the right 7. Put us right here. That would be 1, 2, 3, 4, 5, 6, 7. So our line does go up that way. And then it also continues down and to the left. So we can go down 6 and left 7 if both of them were negative. So that would bring it here. And there we would have parallel lines. And obviously they'd look a little bit more parallel if my graph were drawn to scale properly. But they are parallel. So they would even be marked with the parallel marks, the little parallel arrows. All right, next example. We need to graph the line through point C at -2, -4, and D at 5, 2, and then graph a line through 0, 3 that is perpendicular to line CD. So our first line is going to be the same as our first line from the previous example. So draw our graph. We have a point at -2, -4. That's point C. And a point at 5, 2. That's point D. That's our first line. And we need to make a line through point 0, 3 that is perpendicular. So it needs to be perpendicular. It needs to have a slope that is the opposite reciprocal of line CD. And since this is line CD is the same as the previous problem, we know the slope was 6 over 7. So our slope for our perpendicular line needs to be -7 over 6. Opposite, meaning it's going to have the opposite sign, so now it's negative. And then reciprocal, we're going to flip the fraction. So 7 over 6. So that means if we're drawing this out, we can go up 7 and left 6, and we can go down 7, and right 6. So let's start by going down 7, right 6. 3, 4, 5, 6, 7. And then right 6 would take us 1, 2, 3, 4, 5, 6. And then right there. So drawing this line, and again, if it were to scale, it would be much easier to see that it is perpendicular. So once we have that opposite reciprocal slope, we're able to draw that perpendicular line. All right, that's it for the notes. Make sure you do your homework.